All right, I'm going to talk to y'all today about transformations of quadratics. That's basically where you just move a quadratic function around the graph. First, we've got to talk about the parent function. So on quadratics, there's this parent function, and it's y equals x squared. By parent function, it just means like the original quadratic function. Its axis of symmetry is x equals 0, vertex is 0, minimum 0, zeros are at 0. This is kind of our starting point. So when we talk about movement, we're always assuming that the quadratic starts here and then we're moving it. So the first thing we have is your parabola going to be wide or narrow? Bigger coefficients make narrower parabolas. They call it vertically stretched because it's almost like you took the parabola and kind of pulled it this way and made it more narrow. So in blue, I have my original parent function, y equals x squared. And then in yellow, I have y equals 2x squared. And notice it's a little skinnier, a little narrower. The bigger this number is, the narrower or the skinnier your parabola is going to be. Now that means that if you have these smaller coefficients, then your parabola is going to be wider. So right here again in blue, I have my original parent function. And then in yellow, I did y equals 1/2 x squared. So the smaller this number gets, the wider your parabola is going to be. Okay, now when we actually move it around. First, we have vertical movement. So that's moving it up and down. Now I'll show it all at once and you can copy it down. If we add 2 onto the end, we move the parabola 2 units up on the y-axis, which makes sense because we said this last number is your y-intercept, so it's just increasing it. If we subtract, it moves it down on the y-axis. Pretty simple. Horizontal movement gets a little more complicated just because of the way we write it. G of x is just meaning, hey, it's not the original parent function. The original parent function would be f of x. So anytime we put a different letter in front of it, it just means, hey, we took the original and we changed it. So we have x minus h squared. H just represents some number. Anytime you have it in parentheses like this and you subtract, your parabola moves to the right. If you add a number, the parabola moves to the left. Now this is only if it's in parentheses with the x. That shows left and right movement. All right, and the last one we have are reflections. You're gonna have to pay close attention because there's a very slight difference. Negative f of x means you're reflecting across the x-axis. It would look like y is just negative x squared. Notice the negative is not in parentheses or anything. We said when we have a negative coefficient, that's when it opens down, which makes sense because if our parent function normally opens up, reflecting across the x-axis, it would now open down. Notice the slight difference. This time the negative is in the parentheses with the x. That means we're reflecting across the y-axis. So negative inside the parentheses is a y-axis reflection. Negative outside the parentheses is an x-axis reflection. All right, so here are 2 examples that I want you to try to do on your own. I want you to describe the movement. So in words, tell me, is it moving up? Is it moving down? How far? Go ahead, pause this and describe the movements. Okay, so for this first one, the -5 tells us that we're translating it 5 units down. And then our +2 in the parentheses means we translated it 2 units to the left. For our second one, that -9 means that we translated it 9 units down. Having that 2 in front of it means that it's going to be narrower or stretched vertically. And having a negative inside the parentheses with the x just means it's a y-axis reflection. So you actually don't even have to memorize all this. I took my first example and I plugged it into y equals in the calculator. And if I hit graph, it actually shows me the parabola. So you can see my parent function would have normally been here in the middle. You can see that it went down and to the left. So remember, your calculator can always help you out.